All right, let's talk about hacking the AP Calculus exam. We're going to break down the most common traps, the ones that catch even the sharpest students, and figure out exactly how to step right around them.
Look, you've put in the hours. You know the fundamental theorem of calculus. You've probably practiced related rates problems until your head spins. But all that amazing work can get tripped up in just a second.
Because that's the real test, isn't it? It's often not the super complex theory, it's the small, totally avoidable errors you make under pressure that can tank your score.
So that's what we're going to do right now. We're going to shine a bright light on those traps, figure out why they happen, and build some solid habits to completely sidestep them on exam day.
First things first, let's talk strategy. Before you even think about solving a single derivative, your whole approach to the free response questions can either win or lose you a ton of points.
Let's start with what is, without a doubt, the single biggest source of lost points. On those free response questions, a correct answer with 0 work shown is worth next to nothing. The graders have to see how you got there. Your thought process, your setup, your calculations, that's where the real points are hiding.
Think of it like this. Every single step you write down is another chance to earn points. So why would you leave those on the table by just scribbling down a final number? Don't do it.
Okay, we've all been there. You finish a problem and you get that sinking feeling. I think that's wrong. Your first instinct? Just erase it all, or scribble it out. Fight that urge. Even if your final answer is off, you can still get partial credit for a correct setup or a valid method. Let the grader see what you were thinking. Every single point counts.
All right, now let's get into the nitty-gritty of the calculus itself. We're talking about those subtle concepts where it is just incredibly easy to get tripped up if you're not paying attention.
This is a classic. You got to remember the rule. If a function is differentiable, then it has to be continuous. But, and this is the important part, the reverse isn't always true. A function can absolutely be continuous, but fail to be differentiable.
This graph here shows those exceptions perfectly. So at x equals 0, you see that jump, right? That means it's not continuous or differentiable. But now look over at x equals 1. You can trace that point without lifting your pencil. So yeah, it's continuous. But that sharp corner, that means there's no single defined tangent line. And that's exactly why it's not differentiable right there.
Oh, the f-prime graph. The College Board absolutely loves this one because it really tests if you understand the connection between a function and its derivative. And the most common mistake by far, analyzing the f-prime graph as if it were the graph of the original function, f.
Okay, so remember, when you're looking at the graph of f prime, the question isn't where is this graph going up? The real question is, where is this graph positive? Meaning, where is it above the x-axis? For example, see how f prime is positive between 0 and 2? Well, that tells us that the original function, f, is increasing on that same interval, which is exactly what you see happening in the graph on the right. All right, now for the kind of errors that pop up when the clock is ticking and you can feel the pressure building. These are the simple calculation mistakes that can completely derail a perfect calculus setup. Come on, we've all done it. When you're finding an indefinite integral, that little plus c is just so easy to forget. But it is not optional. That plus c represents an entire family of functions. And if you're doing an initial value problem, finding the specific value of c is literally the whole point of the question.
This one might feel like basic algebra, but I'm telling you, under exam stress, it is a killer. When you're subtracting one expression from another, if you forget to use parentheses, you'll only subtract the very first term and the whole thing goes wrong.
I mean, just look at the difference here. On the left, without this parentheses, you're only subtracting that first term. But on the right, the parentheses make sure you distribute that negative sign to every single term, which completely changes the answer. So please, always wrap the expression you're subtracting in parentheses.
You know the product rule. You've practiced it a million times. But when you're deep in a complex related rates problem and you see an expression like r squared times h, it's shockingly easy to forget that both r and h are functions of time. You absolutely must use the product rule to differentiate it correctly.
Okay, time for a little masterclass. We're going to shift gears from just avoiding mistakes to actually mastering a specific, super high-value skill, how to perfectly interpret the meaning of a derivative in a word problem.
You've seen this kind of prompt on pretty much every free response section, right? It looks a little intimidating, but trust me, there's a simple, repeatable formula for a perfect answer every time.
And here it is. This is the 4-step recipe for a perfect answer. Step 1. What's the input value represent? Step 2. What does the original function actually measure? Step 3, is that derivative positive or negative, increasing or decreasing? And step 4, slap on the correct units. That's it. So let's see how this recipe works. The input, 5, is 5 minutes. The function, h, is the temperature. The sign of the derivative is positive, so the temperature is increasing. And the units, degrees per minute. You put it all together and bam, you've built a perfect point-scoring sentence.
We have covered a lot. So let's lock it all in with one final rapid-fire checklist that you can run through in your head right before you walk into that exam room.
Okay, here are the absolute essentials. Show your work no matter what. Don't you dare cross anything out. Use parentheses when you're subtracting. Add your constant of integration. And for those what does it mean questions, just remember the mantra: input, function, sign, units.
So as you do your final prep, really think about that. Figuring out your own potential weak spots is the final step to acing this thing. Just by knowing where the traps are, you're already halfway to avoiding them. You've got this. Good luck.